Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, motion in a straight line, motion under free fall. First we will discuss kinematic equations or equations of motion for motion under free fall. Then we will also see the three graphical representations, that is position time graph, velocity time graph and acceleration time graph for free fall. Please watch the video completely so that you get all points cleared, and if you think the video is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe my channel now and support me. Also press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the class. In this video, we will discuss motion under free fall. Let us see what this free fall means. When an object is released from rest, a certain height above the surface of the earth, it falls down in a straight line and it is accelerated. Since the object is moving in a straight line, this is motion in a straight line. This acceleration experienced by the object is due to Earth's gravitational force, which is called gravity. The Earth is a huge planet. Its radius is very large. For heights above the surface of the Earth, which is much less than the radius of the Earth, this acceleration due to gravity is considered as constant. Acceleration due to gravity is represented by the letter G. That means the object experiences uniform acceleration. So this is a case of uniformly accelerated motion in a straight line. During its motion downward, the air resistance is neglected. So the ball is said to fall freely, that is without any resistance or hindrance, near the surface of the earth for a certain height. This acceleration due to gravity is a constant and its magnitude is 9.8 meter per second square. What is meant by saying that the object is experiencing a constant acceleration of 9.8 meter per second square? Acceleration is rate of change of velocity. So each second the velocity is increasing by this value of 9.8 meter per second. I will explain it further. When the object is released from the top position from rest, its initial velocity u is equal to 0. During the first second, its velocity becomes 9.8 meter per second. By the second second, the velocity increases by this quantity, that is 9.8 meter per second. That is, it doubles and it becomes 29.6 meter per second. During the third second, it increases further by the same amount, that is 9.8 meter per second, and velocity becomes 39.4 meter per second. Each second, the velocity goes on increasing by the same quantity, namely 9.8 meter per second. Velocity is constantly increasing, so the acceleration remains same. In order to study motion under free fall, we have to slightly modify the equations of motion. We will see that. The downward motion of the object can be taken as positive or it may be taken as negative. First, we will consider motion of the object in the downward direction as positive. Acceleration of the body is equal to positive g. Then the first equation, v is equal to u plus at, becomes v is equal to u plus gt. The object is released from rest. Therefore, u, the initial velocity, is equal to 0. So this equation becomes v is simply equal to gt, equal to 9.8 into t. That is 9.8 t. If t is given, say for example, for 2 seconds, Then we have to multiply 9.8 by this 2. That will be the velocity. The unit will be meter per second. So many meter per second. Now the second equation, S is equal to ut plus half at square. It becomes equal to S is equal to ut plus gt square. Ut becomes 0 because initial velocity is 0. So it becomes S is equal to half gt square. That is 4.9 into t square. If again time given is 2 seconds, then 4.9 into 2 into 2. So many meters. So this is the second formula. Now the third one, v square is equal to u square plus 2as. It becomes equal to v square is equal to u square plus 2gs, where again u square is equal to 0. So v square is equal to 2gs. V square minus u square also is equal to 2gs because v is equal to 0. Now we will consider these equations where the downward motion is taken as negative. In that case, A is equal to negative G. So the first equation will be V is equal to negative GT, negative 9.8 into T. The second equation becomes S is equal to negative half GT square. That is negative 4.9 into T square. The third equation will be v square is equal to u square minus 2gs, which becomes v square is equal to negative 2gs. So when downward motion is taken as negative, acceleration due to gravity is taken as negative, and if it is taken as positive, then acceleration due to gravity is taken as positive. If downward motion is taken as negative, then upward motion is taken as positive. The sign convention should be correctly followed so that you get the answer correct while doing numerical problems. Before we wind up this video, we will just see the three graphical representations, that is position time graph, velocity time graph and acceleration time graph for free fall. I have already prepared the graph. First one is a position time graph. This is the origin. This is positive y-axis. This is negative y-axis. And this is x-axis where time is taken. The object is moving down, so its position is marked on the negative y-axis. This is the shape of the graph. The next one is velocity time graph. This is origin. This is negative y. This is positive y. This is x-axis. Time is taken here. The object is moving in downward direction. Initial velocity is 0. So velocity is taken in the negative y-axis. Velocity increases by the same amount each second. So the graph is a straight line at an angle to the x-axis. It is not uniform velocity, it is non-uniform velocity. It increases uniformly. It changes uniformly. The third one is acceleration time graph. Acceleration is negative 9.8 meter per second square. It is uniform. So it is taken in the negative y-axis. It is a straight line parallel to the x-axis or time axis. Before I wind up, go back to position time graph. Look at the shape of the graph for position time graph. The position is not increasing by the same amount. It is increasing, but it is increasing slowly. So it is in the form of a curve directed downward. Hope this video was of great use to you, and if you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you are watching without subscribing my channel, do subscribe my channel now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.